Okay, let's continue quantum numbers. Quantum numbers are the numbers which are natural solutions in solving the Schrodinger's wave equation. These numbers are used to describe various properties of the orbitals. And what are orbitals? Orbitals are the space around the nucleus of an atom where there is maximum probability of finding an electron, which is inconsequent to Heisenberg's uncertainty principles, whereby we cannot exactly determine the position and the velocity of an electron simultaneously. Okay, let's try to understand the second quantum number, the azimuthal quantum number. It's denoted by the symbol small l. Azimuthal quantum number is also known as orbital angular momentum. Describes the angular momentum of the electron, and is also known as subsidiary quantum number. So L defines what? It defines the three-dimensional shape of the orbital. What will the shape of the orbital is determined by giving a number, and that number is called azimuthal quantum number L. So value of the L will determine the shape of the orbital where the electron is residing. And its value is dependent on the principal quantum number N, which determines the, uh, this, the size, which determines the energy for one electron system. So for a given value of N, the principal quantum number, the value of N will have N values. Okay, for first shell, for N means means enough. Not only it represents the energy, the size, the energy, it also represents the shell. So if the value of N is 1, so value of L is dependent on N. The value of principal azimuthal quantum number is dependent on the value of principal quantum number. And how many values of L are possible for a given value of N? N values are possible. And what does it mean? Say for ranging from 0 to N minus 1. 0 to N minus 1. Let's try to understand. Say for a given value of N, the value of L will be 0, right? It can be 0, it can be 1, it can be 2, it can be 3, it can be 4. It will be up to N minus 1 value. And there will be N values, N number of values. Okay, let's try to understand with few more examples. Say for N is equal to 1, for the first shell that we denote by the capital K, the value of L will be how much? The value will be L will be 0 up to N minus 1. N minus 1 is how much? 1. 1 minus 1 is 0. So it will have only one value. L equals 0. So there is... Okay, what does it mean? L can have N values. So for example, N equal to 1. So how many values of L are possible? Only one value of L is possible. If N is equal to 2, how many values of L are possible? 2 values of L are possible. If N equal to 3, how many values of L are possible? 3 values of L are possible. Or 3 values of azimuthal quantum numbers are possible. That's what it means. For a given value of N, L, how many values of L are possible? N number of values are possible. And what about what are the values? That is a possibility is up to N value. And what are the what will be the numbers? It will be start from 0 till N minus 1. That means one number less than the given value of N. Say N equal to 1, the possible values of L is only 1, that is 0. For N equal to 2, the possible number of values are N, that is there are 2 values of L possible, and what will be there? What will be, and what are they? 0 and 1. How do you know this? Up to 1, it will be up to N minus 1. 2 minus 1 is 1, so up to 1. And if N equal to 3, how many values of L are possible? 3 values are possible. And what are they? It will be 0 up to N minus 1. N minus 1 is how much? N is 3. 3 minus 1 is 2. Up to 2. So 0, 1, 2. So that means for K shell, okay, for N equal to 1, the values of possible values of L is only 1, and that is 0. For N equal to 2, L will have values 0 and 1, 2 values. For N equal to 3, and L will have 3 values. 0, 1, and 2. Okay, the principal quantum number determines the shell, the first shell, the second shell, the third shell. And azimuthal quantum number, the principal quantum number, it also tells the subshells. For example, it will have n subshells. Like n values means n values means n subshells. So first principal number is 1. How many subshell will be there? There will be one subshell. The second principal quantum number is 2. Right? Second shell. How many subshell will be there? There will be 2 subshells. The third principal quantum number is n, or m shell. How many subshells will be there? There will be 3 subshells. The value of n not only determines the shell, it also determines how many subshells will be there in that shell. And we have a notation for the azimuthal quantum number. For example, if this value is 0, we notify it with small s. If the value of principal quantum number is 1, we use a small notation, a letter, small p, then small d, then small f, and small g. If n l equal to 0 means s, l equal to 1 means p, l equal to 2 means d, l equal to 4 means f, small f, and l equal to 4 means small g. So there are instead of writing with numbers, sometimes we use small letters S, P, D, F, and G, and others also there, H and all, and it goes on, which determines the azimuthal quantum number or the three-dimensional shape of the orbital, and it is also used to write the subshell notations that we'll learn in our next slide. Fine.